press the bell icon on the YouTube app and never miss another update.
Hello students, we continue what we stopped in the last class. The next problem. Before that, I once again explain. In the last class we discussed one very important theorem. The theorem is limit theta tends to 0. Yes, sin theta divided by theta is equal to 1. This is very important theorem, and we solve some problems regarding this theorem. Correct? We continue some more problems regarding this theorem. Next problem. So limit x tends to pi, limit x tends to pi. Observe this problem, very interesting. Sin of pi minus x divided by pi into pi minus x. Sin of pi minus x divided by pi into pi minus x. Pi minus x. So here it is pi is a constant. We write it as outside. Before that, if you want, we substitute the pi value first. Pi minus pi sin 0, correct? Sin 0 divided by pi minus pi into 0, 0 into pi is 0. So no doubt answer is 0 by 0 indeterminate form. This is very important. First we substitute the values. What we got the result. Okay, so here we got indeterminate value. The next step, that implies we take once again this problem. X tends to pi. Sin of pi minus x divided by pi into pi minus x. This pi we write it as outside. 1 divided by pi into limit x tends to pi. Sin of pi minus x divided by pi minus x. Okay, is it 1? No. Here pi minus x, here pi minus x, but here x tends to pi. If x tends to 0, then only it is 1. So all these three values and this one, this is 0. Pi minus x, here also pi minus. If all these three values same, and this in place of pi, if it is 0, then only it is 1. Okay, so what I do, put pi minus x is equal to theta. Substitution method. Here x tends to pi. When x tends to pi, in place of x I substitute pi. Theta tends to pi minus pi. Theta tends to 0. Pi minus pi is what? 0. That is equal to 1 divided by pi into limit theta tends to 0. Pi minus x is what? Sin theta divided by theta. Observe, it is 1. So answer is 1. Observe this problem. Very simple problem. Very interesting problem and very important problem. Please observe first this problem very carefully. Next problem. Next problem. Limit x tends to 0 cos x divided by pi minus x. Cos x divided by pi minus x. Firstly, we substitute the values. Cos 0 What is the value of cos 0? It is 1. 1 divided by pi. Is it indeterminate value? No, it is a finite value. So it is a finite value and unique value. That is the limit value. Over. The problem is over. If it is indeterminate, we go for another step of simplification. So here we got the result, a finite value, a unique finite value. So if it is a unique finite value, then it is the limit value. Next problem. See, very simple problem this one. Limit x tends to 0, tan x divided by x. X tends to 0, x tends to 0, tan x divided by x. Firstly, we substitute the value first. What we got the result? Tan 0 divided by 0. It is 0 by 0. Indeterminate form. Then we take LHS. Sorry, that implies we take the problem once again. X tends to 0. Tan x divided by x. Tan x divided by x. So tan theta we can return as sin theta by cos theta. Limit x tends to 0. Sin x divided by cos x whole divided by x. Sin x divided by cos x whole divided by x. So the next step that is equal to limit x tends to 0. Sin x divided by x into cos x. We write like this. Yes, no problem. Both are same. This one is also. Both are same. Again, limit x tends to 0. Limit x tends to 0. Observe the simplification. I separate this one. These two result 1 by cos x. I separate it. Is it change? No. It will remain same. Again, what I do? Limit x tends to 0. I apply the limit separately. This is what f of x and this is what g of x. You know the algebra of limit. Limit x tends to a, f of x into g of x. We can return as limit x tends to a, f of x into limit x tends to a, g of x. So, into limit x tends to 0, 1 by cos x. 1 divided by cos x. This result is 1. Correct? 1 into 1 divided by cos 0. In the place of x substitute 0. We write the reason. Since limit theta tends to 0, what? Sin theta by theta is equal to 1. Sin theta divided by theta is equal to 1. What is the value of cos 0? Cos 0 is 1. 1 divided by 1. Answer is 1. So, therefore, one more theorem. X tends to 0. Tan x divided by x is also 1. This is one more formula. If you call it as theorem 3 also, no problem. What we see, limit theta tends to 0, sin theta by theta is 1, same. Limit x tends to 0, tan x divided by x. Tan x divided by x is also 1. Very important. Is also 1. Observe this one first. Observe this carefully. Carefully you have to observe the proof. Very important proof. So practice it. This is very important. If you want, you call it as theorem 3 also. Prove that limit x tends to 0, tan x by x is equal to 1. This is the method. This is the procedure. Next one. Next problem. Limit x tends to 0. 1 minus cos x by x. 1 minus cos x divided by x. X tends to 0. 1 minus cos x divided by x. Firstly, we substitute wherever x 0. 1 minus cos 0. Cos 0 is 1. 1 minus 1 is 0. 0 by 0. Indeterminate form. Correct? Okay. You know the trigonometry. But cos 2x. Cos 2x. Cos 2x, 3 formulas. Cos square x minus sin square x, 1. Which one? 1 minus 2 sin square x. Correct? Third one, 2 cos square x minus 1. 2 cos square x minus 1. In trigonometry, you know these 3 formulas. Correct? So what I use second one. Observe here. Cos 2x we can run as 1 minus 2 sin square x. Correct? Cos 2x is equal to 1 minus. First step, I shift 1 from right side to left side. It becomes minus 2 sin square x. So I take minus common and cancel that. It becomes 2 sin square x. This is very important result. 1 minus cos 2x. Observe this one. 1 minus cos 2x we write it as 2 sin square x. 1 minus cos 2x we write it as 2 sin square x. Similarly, 1 minus cos x, 2 sin square x by 2. Because I divide here 2, here also, here not, in the angle I divide by 2, here also divide by 2. So 1 minus cos x, 1 minus cos x. This is one more result. You know in trigonometry, 1 minus cos 2x we written as 2 sin square x. 1 minus cos x is equal to 2 sin square x by 2. 2 sin square x by 2. Why we write this one, sir? In place of 1 minus cos x, I write 2 sin square x by 2. Correct? Write it. That is equal to limit x tends to 0 by 2 whole divided by x. This is the first step. Understand? Okay. 2 right outside, 2 into both are same. A square we write it as a into a. That's why sin x by 2 into sin x by 2. 2 into limit x tends to 0 sin x by 2 by x into sin x by 2. Sin x by 2. We separate the limits. 2 into limit x tends to 0 by x. Limit x tends to 0 Sin x by 2. Sin x by 2. Because we know the algebra of limit. Limit x tends to a f of x into g of x. Here it is x by 2. Here also we want x by 2. 2 into limit x tends to 0. Sin x by 2. Multiply and divided by 2 here. This result as it is. Later we apply the result. Okay, sin just only the one term, sin x by 2. Sin x by 2. This 2 we write it as outside. 2 what? Get cancelled. Write it here. Observe here. This 2 right outside. Limit x tends to 0. Sin x by 2 by x by 2 into limit x tends to 0. Only one term, sin x by 2. So 2 get cancelled. As x tends to 0, x by 2, 0 by 2, 0, that is equal to limit x by 2 tends to 0, sin x by 2 divided by x by 2 into limit x tends to 0, sin x by 2. This is what? This is 1 into sin. Wherever x substitute 0, sin 0 by 2. 1 into sin 0. What is the value of 0? 0. The answer is 0. The answer is 0. Here only we substitute, no problem. But this simplification is very important. Here only we write 0. 0 anything is 0. Answer we got. But this simplification is very important. That's why I simplified. Here only we directly write 0 into anything is 0. We got the result. But this procedure is very important. That's why I keep this one as it is. Understand? So 1 into sin 0, the value of sin 0 is 0. 0 into 1 is 0. 0 is a finite value, not indeterminate value. 0 by 0 is an indeterminate value. So it is a finite value. So this problem, the answer is 0. Observe this problem. Observe, very important. Very carefully you have to observe. Next problem. Next problem, limit x tends to 0, cos 2x minus 1, cos x minus 1, cos 2x minus 1, cos x minus 1. Firstly we substitute. Wherever x 0, cos 0 minus 1, cos 0 minus 1, 1 minus 1 0, because these values are 1. Indeterminate form. Correct? Okay. What we do? So we know that 1 minus cos 2x is nothing but 2 sin square x. Correct? 1 minus cos x. Just now I simplified these two. Sine square x by 2 sine square x by 2. Cos 2x minus 1, cos x minus 1. In these two terms, what we do, we take minus common. Here I take minus common, 1 minus cos 2x. Here I take minus common, 1 minus cos x. Minus minus get cancelled. So 1 minus cos 2x. 1 minus cos x. 1 minus cos 2x divided by 1 minus cos x. 1 minus cos 2x we written as 2 sin square x. X tends to 0. 1 minus cos 2x. 1 minus cos x, 2 sin square x by 2. 2, both sides get cancelled. What left? Limit x tends to 0, sin square x divided by sin square x by 2. Sin square x divided by sin square x by 2. Limit x tends to 0. That this I can write as sin x divided by sin x by 2 whole square. A square divided by b square, we write it as a by b whole square. A power m divided by b power m, we write it as theory of indices, a by b whole power m. So this one we write it as limit x tends to 0, sin x divided by sin of x by 2 whole square. Algebra of limit. One property I discussed. If not remember, see this problem. X tends to a, f of x to the power n correct, whole to the power n, same right. Next step. That is equal to, I write here, I apply separate limit before that what we do, we divide both numerator and denominator by x, sin x by x x by 2 by x. Whole square. Here what I do, I divide both numerator and denominator by x. We separate the limits. Sin x divided by x 1 over sin x by 2 divided by x whole square, no problem. This numerator is 1, x. Is it denominator 1? No, x by 2 is there. Here x is there, here x is there. Here also we want x by 2. Here also we want x by 2. What we do? That is equal to, we write the numerator as it is, the problem. Sin x limit x tends to 0, sin x by 2 multiply and divided by 2 whole square. Multiply and divided by 2. See, observe here. Multiply and divided by 2. Correct? Sine multiply and divided by 2. Okay. Then denominator by denominator. So this 2 we rated as outside, but denominator by denominator goes to numerator. 2 into, it goes to numerator. 2 into limit x tends to 0 sin x by x whole divided by limit x tends to 0 x by 2 x by 2. Observe here, this is firstly I rated as outside 1 by 2. Correct? Observe this one. I read direct 1 by 2. Here if I shift from outside of the limit 1 by 2, denominator by denominator goes to numerator. 2 into whole square. Whole square, because this square is there. As x tends to 0, x by 2 also tends to 0. 0 by 2 is also 0. So over 2 into limit x tends to 0 sin x by x whole divided by limit x by 2 tends to 0 sin x by 2 x by 2 whole square. 2 into 1 divided by 1 whole square. The reason only 1. Limit theta tends to 0 sin theta divided by theta is equal to 1. Sin theta by theta is equal to 1. So the answer is 2 square. 2 square is what? 4. 2 square is 4. See the problem. See the problem. Each and every step simplification. See, very, very important problem. Observe every steps. Next problem. Next one. Limit x tends to 0 ax plus x into cos x b sin x, ax by x into cos x, x into cos x, sorry, ax plus, not by, ax plus x into cos x by b sin x. Firstly, we substitute wherever x 0. Sin 0. A into 0 is 0. 0 into cos 0, 0 into 1 is 0. B into sin 0, 0, 0 by 0. Indeterminate form. Indeterminate form. Okay. X tends to 0. what we do, in the numerator we take x common. If I take x common, a plus cos x, b sin x. This is the first step. In the first step, what I do, I take x common. We shifted it by denominator. It shifted by denominator by denominator. Cos x by x. Denominator by denominator goes to again numerator, result will same, never affected. Correct? Sin x by x. B is a constant, write it as outside. Right here. One divided by b, limit x tends to 0. Sin x by x, a plus cos x divided by sin x by x. We apply separate limit by using algebra of limit. Sin x divided by x, sin x divided by x. So 1 divided by b, numerator is a plus cos 0, denominator is 1. Write the reason. Sin theta by theta is equal to 1. Sin theta divided by theta is equal to 1. Okay, 1 divided by b, a plus 1, cos 0 is 1. So answer is 1 plus a divided by b. The answer is 1 plus a divided by b. See this problem, 1 plus a divided by b. Very important problem. This is also very important problem. 1 plus a divided by b. Next problem, very important one. Next one, limit x tends to 0, x into secant x, x into secant x. Limit x tends to 0, x into secant x. Okay, we substitute the result, 0 into secant 0. Secant 0 is 1. Answer is 0. So we got a finite value. That should be the limit value. That should be the what? Limit value. Next problem. Limit x tends to 0. Sin ax plus bx divided by ax plus sin bx, ax plus sin bx. Limit x tends to 0, sin ax plus bx divided by ax plus sin bx. Okay, first step, wherever x we substitute 0. Sin 0, 0, 0, sin 0. indeterminate form. Understand? Indeterminate form. Okay, what we do, we write once again. That implies in the numerator we take x common, in the denominator we take x common. We write like this. If I take x common in the numerator, it becomes sin ax divided by x plus b. In the denominator, if I take x common, a plus sin bx divided by x. Correct? Observe this one. I take x common from the numerator, it becomes sin ax by x. X common from the denominator, a plus sin bx by x. Xx get cancelled. Xx get cancelled. So then that is equal to limit x tends to 0 sin ax divided by x, for that multiply and divided by a plus b whole divided by a plus sin bx divided by x, for that multiply and divided by b. Here multiply and divided by b, here multiply and divided by a. We separate the limit. A into sin ax divided by ax plus b whole divided by limit x tends to 0 a plus sin bx divided by bx into b correct, into b. Okay, since or else as, okay, one step we write as x tends to 0, ax also tends to 0 and bx also tends to 0. So we apply the limit a into limit ax tends to 0 sin ax divided by ax plus constant, write it as it is, whole divide. A is a constant as it is, plus limit bx tends to 0 sin bx divided by bx, sin bx divided by what? Bx. Next up, a into 1 plus b divided by, correct, a into 1 plus b divided by a plus b into 1. The reason is limit theta tends to 0 sin theta divided by theta is equal to 1. A plus b, answer is 1. Answer is 1. Observe this problem. Observe the steps. Each and every steps you have to observe. You also write. You also write once again and see the problem very carefully. Then only you are perfect. Observe the steps. Next problem. Next one, limit, next problem, limit x tends to pi by 2 tan 2x pi by 2, x minus pi by 2, limit x tends to pi by 2 tan 2x divided by x minus pi by 2. Firstly we substitute the value wherever x pi by 2 into pi by 2, pi by 2 minus pi by 2, 2 get cancelled, tan pi by 0, tan pi is 0, 0 by 0, indeterminate form, correct? It is an indeterminate form. What we do? We write once again, that implies we solve this by substitution method. What we do? X minus pi by 2 is theta. Put, observe the problem, x minus pi by 2 is equal to theta. When x tends to pi by 2, when x tends to pi by 2, comma, theta tends to pi by 2 minus pi by 2, in place of x substitute pi by 2, theta tends to 0, correct? Theta tends to 0. When x tends to pi by 2, theta tends to 0. One more, x minus pi by 2 is theta, since x minus pi by 2 is theta, correct? But we want 2x, x is equal to theta plus pi by 2, correct? Theta plus pi by 2. If we multiply by 2x, 2 theta plus pi, 2x written as pi plus 2 theta, a plus b, b plus a, both are side, 2x written as pi plus 2 theta. So that is equal to limit, when x tends to pi by 2, theta tends to 0, theta tends to 0, tan of pi plus 2 theta divided by theta, pi plus 2 theta divided by theta, tan 180 plus theta, 180 plus theta lies in third quadrant tan is positive, 180 plus theta tan theta, limit theta tends to 0, tan 2 theta divided by theta, correct? 2 theta divided by theta. For that what we do? We multiply and divide by 2. We write 2 outside, 2 into limit theta tends to 0, tan 2 theta divided by 2 theta. As theta tends to 0, no doubt 2 theta also tends to 0. So I write here, as theta tends to 0, 2 theta also tends to 0, 2 into limit 2 theta tends to 0, correct? And 2 theta divided by 2 theta, 2 into 1, since limit theta tends to 0, tan theta by theta is equal to 1. So answer is 2. Answer is 2. Answer is 2. Observe this problem. This is very important problem. Very important problem. Observe every steps. Every steps observe the problem very carefully. So the answer is 2. We solve one more problem. Next problem. Limit x tends to 0, cosecant x minus cot x. Limit x tends to 0, cosecant x minus cot x. Firstly, we substitute the value. Cosecant 0 minus cot 0. Cosecant 0 is what? Infinity. Cot 0 is what? Infinity. Infinity minus infinity. It is also an indeterminate form. Then that is equal to limit x tends to 0. Cosecant x are written as 1 by sin x. Cosecant x we write as 1 by sin x. Cot x, cos x divided by sin x. Cos x divided by what? Sin x. We take LCM sin x. If I take LCM sin x, in the numerator become 1 minus cos x. 1 minus cos x divided by what? Sin x. Once again we substitute the limit value. Here we got infinity minus infinity. 1 minus 0. Cos 0 is 1, 1 minus 1 is 1. Sorry, 1 minus 1 is 0. Sin 0 is 0, 0 by 0. Firstly, we got infinity minus infinity. After simplifying, we got 0 by 0. Again, it is indeterminate form. Correct? Again, it is indeterminate form. So, 0 by 0. Correct? 0 by 0. Then, how to solve this one? See this one. Limit x tends to 0. 1 minus cos x 2 sin square x by 2. Just now in the last class we write 1 minus cos x written as 2 sin square x by 2, and sin x 2 sin x by 2 into cos x by 2. How it is, sir? Correct. So see this one. You know, in the trigonometry, sin 2x is nothing but 2 sin x into cos x. 2 sin x into cos x. Correct. So sin x I divided by 2 here. 2 sin x by 2 into cos x by 2. 2 sin x by 2 into cos x by 2. So in place of sin x, this is very important. In place of sin x, only in the angle I divide, not here. So we have to divide by here only. We have to divide by here only. So 2 sin x by 2 into cos x. Here 2 get cancelled. So sin x we written as 2 sin x by 2 into cos x by 2. 2 get cancelled. Correct? 2 get cancelled. One term get cancelled. Limit x tends to 0. Limit x tends to 0. What left? Sin x by 2 divided by cos x by 2. Sin x by 2 by cos x by 2. Sin theta by cos theta tan theta. Limit x tends to 0. Tan x by 2. Correct? Sin theta by cos theta. There is nothing but what? Tan theta. Tan x by 2. Tan x by 2. Substitute here. Tan 0 by 2. Tan 0 is 0. The answer is 0. Finite value. It is not an indeterminate value. 0 by 0 is an indeterminate value. So answer what we got? Answer is 0. This is also very important problem. See this problem first. Carefully you have to observe this problem. Each steps you have to observe this problem. Very important problem. One more problem. Limit x tends to 0, sin 3x divided by 6x. Sin 3x divided by 6x. Then how to solve this one? So again it is no doubt 0 by 0 indeterminate form. This 6 we write it as outside, 1 by 6 into limit. In the last class we solved this problem, sin 3x divided by x. For that multiply and divided by 3, correct? So in the last class we solved same type of problem, sin ax divided by bx. This 3 we write outside of the limit, 3 by 6. Limit x tends to 0, what? Sin 3x divided by 3x, correct? Sin 3x divided by 3x. As x tends to 0, 3x also tends to 0. 1 by 2 into limit 3x tends to 0, sin 3x divided by 3x. So 1 by 2 into 1, correct? 1 by 2 into 1. Why it is 1? Since limit theta tends to 0, sin theta divided by theta is equal to 1. Final answer is 1 by 2. Final answer is 1 by 2. Observe this problem also. Final answer is 1 by 2. Okay, up to this we stop. We continue the remaining concept or remaining problems in the next class. Thank you.